Hello and welcome to the Peatlands. In the previous videos we explained how to identify pedogenic zones and soil horizons. In this video we would like to focus on the drop shatter test with a subsequent aggregate size sorting. The different types of pedal soil structure exhibit varying degrees of stability during mechanical stress. The degree of stability can be used as an identifying criterion for soil structure types and therefore for horizons. However, depending on how you handle the material, the peat will break into smaller or larger elements. In order to identify the soil structure types and the dominant aggregate size in a reproducible manner, the soil should be exposed to a standardized force. Therefore, the drop shatter test is recommended for all horizons with distinct pedal structure. For a start, you first need a soil monolith where soil horizon boundaries have already been identified, a solid plastic container, and a rectangular marking on a solid base. We used a light board with a dimension 60 by 40 centimeters and a plastic bag with a rectangular marking on it. Because the soil horizons will be investigated from top to bottom, the soil structure types and the aggregate sizes should also be looked at in this order. We will start by separating the first horizon from the monolith. This material should be dropped from a height of 1 meter into the plastic container. Aggregates which are still connected should be separated by hand. In this way, the soil structure type can be best identified. Afterwards, the material will be laid out on the rectangular hard surface and the aggregates will be sorted along the long side of the rectangle according to size. Now the dominant aggregate size can be identified. Intensively drained sites usually have more than one horizon with clear aggregate formation. In this case, the same procedure will be repeated for the second horizon. The horizon will be separated out, dropped, taken apart, and then sorted. This will be repeated for all of the following horizons that have a pedal structure, with the exception of peat shrinkage horizons with few shrinkage cracks whose structural elements cannot be cleanly separated from the apedal material below. And now a few tips on each individual step. When you separate the horizons for the drop shatter test, please note that the horizon boundaries are not always level. An example of this is the border between horizon 2 and 3 of this site. You should only take material for the drop shatter test which belongs to the examined horizon following the shape of the transition zone. This is valid for all horizons with well-developed distinct pedal structure. In case the material spanning a horizon boundary is held together by roots, the horizons can be carefully separated using a knife tip. It should not, however, be totally cut through, as this would damage the aggregates. When the material is loose, it is not always easy to remove it in one piece. Leftover material from the examined horizon will likewise be used for the drop shatter test. This is done after the previous batch has already been dropped, taken apart, and put onto the rectangular surface. When the soil is dropped into the plastic container, the soil should simply fall vertically from a height of 1 meter and should not be actively thrown down or from the side. Because of the root density on grassland sites, the first horizon may not fall apart much after being dropped. The fine aggregates should be separated by hand from among the roots. This is done by carefully breaking the sod open, pulling it apart, and pressing on the soil material. While doing this, you should only use as much force as is necessary so that softer aggregates are not squashed. The degree of stability can be investigated by taking aggregates which still hold together and lightly pressing them between the fingers. You should only press as hard as you would if you were checking a fruit for ripeness. Let's call this the ripe fruit rule. The dense root mass can be shaken out and discarded. The drop shatter technique will not work if the first horizon is wet. For example, the spongy granular structure of a weakly earthified horizon cannot be separated cleanly. The drop shatter test is therefore not suitable for such horizons. Grassland sites often have a reaggregation horizon as their second horizon. Weakly re-aggregated peat falls apart stepwise into finer aggregates when pressed using the ripe fruit rule. Decaying subsets should only be pressed stepwise a maximum of 3 times to get to the aggregate size that will be recorded. In most horizons with pedal structure, even in those of the pedogenic zone B, part of the aggregates will still be held together by roots. These aggregates must be taken apart by hand as long as a natural aggregate surface exists between them. While sorting the aggregates, it should be noted that these should be arranged as best as possible in an even layer on the rectangular surface. Here, for instance, you can see 3 horizons of a fan site which have been dropped and sorted. The final goal is to be able to identify the horizons and their characteristics on the prepared soil monolith. The drop-shatter test and the sorting of aggregate sizes are relatively time-consuming. They are, however, very helpful in the training phase. With the drop-shatter test, you learn how the soil feels and how stable different soil structure types are. Through the sorting of the aggregates, you can learn to estimate the dominant aggregate size better, which is also a criterion for horizon identification. The principle of sorting aggregates was taken from the visual soil assessment tool, which was developed for mineral soils used in agriculture. You can find more information about this in the original source shown here. Less experienced soil surveyors can use the drop-shatter test and sorting to develop a better standardized routine. With time, it becomes possible to first eliminate the sorting and then the drop-shatter test and identify soil characteristics directly in the monolith. What should be kept is the light finger pressure following the ripe fruit rule. It can always be used on individual aggregates in the monolith. Here again are all the steps at a glance. See you soon!